So, hello everyone. Today we are going to talk about section 7.4, integration of rational function by partial fraction. So the first question is, what's rational function? So we have to know, our object. Otherwise, we don't know what we are doing. Okay. So if we have a function f(x), this function can be written as px over qx. Okay, here px and qx are polynomials. They are polynomials. If a function can be written as in this form, we call it rational function. So we call f(x) rational function. Or sometimes the people just say fraction, right? Or fraction function, it depends which language you do like, but they are the same. Anyway, that's fine. So I will keep using rational function. So I will, follow the textbook. So our goal in this part is, okay, if we have a rational function f(x), it is written as this, right? How do we compute, right, the antiderivative of f(x)? So this is the goal, right? So let's first introduce some notation. So first, give a definition. You may know in your high school, but I just review it. So if we have a function px, it can be written, it is written as an minus 1 x n minus 1 plus a2 x2 plus a1 x plus a0, and an is not 0. So if an is 0, the first term is a minus 1. Why do I write it out, right? So it means that if I write it in this format, I already assumed an is non-zero. So, and then the degree of px is n. Okay, this is the degree. Okay, so furthermore, if f(x) written as px, qx, the degree of px is m, the degree of qx is n. So the first case is we say f(x) is proper if m is less than n. It means that the degree in the numerator is smaller than the degree on the denominator. Okay, we say f(x) is improper if m is greater or equal to m. So what proper means that the degree in the numerator is bigger than the degree in the, proper means that the degree of the polynomial in the denominator is greater than the degree of the polynomial in the numerator. Okay, otherwise it's improper. So For the second case, if fx is improper, so fx in P is px over qx if it's improper, and then f can be written as sx plus rx over qx, such that sx is a polynomial and px over qx or prime. No, sorry, let's write in other place because what happened. And p prime x over q prime x is a proper rational function. Okay. A, B. Okay. So our next step is let me give you some example. So the first example is find the antiderivative of x plus x cubic plus x over x minus 1 and dx. So first, let's say fx is x power to 3 cubic plus x over x minus 1. So now px is x cubic plus x, right? Qx is x minus 1. You can feel the degree of px is 3, which is greater than the degree of qx, right? So this is improper, right? So if it is improper, what do we do? So we have to write fx. We have to write fx in sx plus p prime x over q prime x. Okay, sorry. Here the prime. Okay, let me change my language. Okay, so let's write. Otherwise, p1x, q1x, p1x, q1x. Okay, right is p1x, q1x. Okay, so that's our goal. Okay, how do we do that? I think you may know this, right? This is called a long division, right? I think you studied this in your high school. If you don't know, okay, let's just do it here. So this is improper. We write x plus x divided by x minus 1. So we get this x squared. So get x squared minus x cubic minus x squared, and then subtract from x cubic plus x. So we get x cubic plus x, right? And then let's plus x, right? So we get this is x squared minus x, right? So we get 2x, right? 2x, and then we plus 2, so we get 2x minus 2, so we get 2. So by this long division, so we have x cubic plus x, it should be equal to x minus 1, x squared plus x plus 2 plus 2, right? This is long division. You may know this. Okay, and then, so fx is x cubic plus x over x. So we get this is x plus squared plus x plus 2 and plus 2 over x minus 1. So for this problem, so we have x cubic plus x over x minus 1 dx. So which is by the computation, or you can say by long division. That's okay. X squared plus x plus 2 and plus 2 over x minus 1 dx. So the antiderivative for this term, antiderivative is 1 over 3x cubic plus half x squared plus 2x plus 2 ln x minus 1 absolute value plus c, right? So you may say, why do I give this example? For this example, I want you know the long division. In case you forget, I know in US you studied this in your high school. Okay, so this is a very basic example. So let's go to our general case. So it's kind of let's study what's partial fraction. This is a technique. So if we have a function f(x) is px over qx, so we assume f(x) is proper. You may ask me, what if f(x) is improper? So if f(x) is improper, you can use the long division. Look at here, right? You use the long division. You get a polynomial, and then you have an improper function. Oh, you have a proper function, sorry. Okay. So let's look at this case. f(x) is proper function. And then there is a big theorem. You don't have to memorize this. Just get the feeling, because when you are doing a problem, you don't have to, you don't have to study it. So if we have an improper function, and then the theorem says, okay, proper function px over x can be written as the sum of partial fraction of the form a over ax plus b I, or ax plus b over ax squared plus bx plus c over j. So means that px over qx can be written as the sum of this form, this or both, or some terms like this. So let's look at examples, so you will understand it better by examples. So let's look at case 1. Case 1 is for our partial fraction f(x), which is px over qx. So qx is this form, a1x plus b1 and a2x plus b2 and akx plus bk. Means that ak or qx is the product of distinct linear factor. Okay, like this. So if a problem like this, so we still assume this is proper. Okay, now we're talking about a proper, right? So like what? I explained before, if it's improper, use the long division. You get a polynomial plus a proper rational function, and then means that we only need to deal with the proper rational function. So this, if px over qx is the product of linear factors. So this rational function can be written as in this form. Okay. So just know this. You may ask me, what's A1, A2, AK? So that's our question. You have to compute. So here A1, AK is undetermined coefficient, you know, is in R, is real number. We have to calculate AI. That's our goal. So let's look at examples. Example 2. So this is example x squared plus 2x minus 1 over 2x power to 3 plus 3x squared minus 2x dx, right? So if you look at this first, f x is this 2x cubic plus 3x squared minus 2x is proper, right? Because the degree, numerator, the degree is 2. Now the polynomial on the denominator is degree 3, right? So it's proper. So, and then let's look at qx is 2x cubic plus 3x squared minus 2x. So we can get this is x 2x squared plus 3x minus 2, right? Furthermore, so we can factor out of this, right? So this is 2x minus 1 and x plus 2, right? So now our qx can be written as a product of different linear factor, right? So it means that x squared plus 2x minus 3 over 2 cubic plus 3x squared minus 2x can be written as a over x plus b over 2x minus 1 plus c x plus 2, right? Our goal here, you know, if we know ABC and then we compute the integral, it's quite easy to compute the integral, right? For each term. So our goal here is to find A, B, C. How? So we just multiply by this term on both sides. So we get x squared plus 2x minus 1 is a 2x minus 1, x plus 2, right? Plus b, right? X plus 2 plus c, x 2x minus 1, right? So we have to, you know, simplify the right-hand side. So the right-hand side, you simplify it. You know, you simplify it by yourself. So we will get 2a plus b plus 2c x squared plus 3a plus 2b minus c x minus 2a. So here, compute this by yourself. You know, I computed by myself, you know, because when you are doing problem, you have to repeat this process. Just compute this, and the third term, and you add them together, by the order of the x squared, x, and constant term. So if we look at both sides, so we will get this QA plus B plus 2C is 1, 3A plus 2B minus C is 2, right? The coefficient is 2. So the constant term is negative 2A is negative 1, right? So we get, we get linear, we'll get 3 equations, right? So our next step is solve AB. From this, you can solve A is half, right? And then you plug in A equals to half into first 2 equations, right? So we will get 1 plus B plus 2C is 1, right? 3 over 2 plus 2B minus 3 is 2. We continue to simplify. To this is 0, and this is 2B minus 3 is half, right? And then from this we can solve. Okay, B is 1 over 5, and C is 1 over 10. So this do it by yourself. This is very important. I think you know this in your high school, right? You have to practice this by yourself. Okay. So by this computation, we get x squared plus 2x minus 1 over 2x cubic plus 3x squared minus 2x, which is A is half. So get a 2x, 1 over 2x, plus B is 1 over 5. So we get 5, 2x minus 1, 1, plus C is negative 10, or negative 1 over 10. So we minus 1 over 10, x plus 2. Okay. So that's why we studied the partial fraction, right? So, and then we integrate this on both sides. Okay, on both sides, sorry. So that's my way. I have to keep the notation. So we integrate this on both sides, right? So for this term, the antiderivative is ln x, right? This term, the antiderivative is 1 over 10 ln 2x minus 1. This term is 1 over x plus 2, the absolute value. Don't forget to say, right? So you may ask me, how do we compute this, right? For this, you can set u is 2x minus 1, and then by u substitution. Okay, you have to be very familiar with the u substitution. That's very important. Okay, so that's our first example, a second example. So let me give you one more. So example 3, find dx over x squared minus a squared and dx, right? So you can say fx is 1 over x squared minus a squared, right? This is a rational function, and also it's proper, right? and qx is x squared minus a squared. So this is x plus a times by x minus a. Right. By the case 1, so we have this is a over x minus a, right? Plus b, x plus a. So we have to go here, find a and b. How? Multiply by x squared minus a squared on both sides. So we get 1 is ax plus a plus bx minus a. Right? We simplify the right-hand term. We get a plus bx, right? Plus a minus b, a, right? So this is 1. So means that because there is no x on the left-hand side, a plus b is 0, right? A minus b times a, this is the constant term. A is a constant, we know. And also we assume a is not 0. Otherwise, it's too easy. So this is 1. And then we can solve this. So we get a is 1 over 2a. B is negative 1 over 2a. You have to do it by yourself. By yourself. I think you did this kind of problem a lot in your high school. Okay, so we have this 1 over x squared minus a squared dx is equal to, okay, 2ax minus a plus, or minus, right? Plus negative, so it's minus. Minus, right? 2ax plus a dx, right? The antiderivative for the first term, right? The antiderivative for the first term is, of course, you can, this is 1 over 2a and ln x minus a minus 1 over 2a ln x plus a, right? Don't forget add the extra side. That's very important, because we are studying, the antiderivative. So if you forget the say, anyway, that's what I'm saying. It's very important. You cannot forget. Oh, and then let's continue to simplify. So we get 1 over 2a ln x minus a, x plus b, absolute value, plus c. Okay, this is our first, no, this is our case 1. So I will end this recording. In the following recording, we will continue to study case 2, case 3, and case 4. Okay, let's stop here for this recording. So just like, okay, let me write a remark. Case 1, what's case 1? Qx can be written as this. The product of the linear factor term. Okay, what I want to say is here, the linear factors are distinct, mean they are different. It's very important. Okay, it's distinct. Okay, that's our case 1. So let's stop.